Ozone is frequently used for the cleavage of double bonds, and the simple apparatus shown here will suffice for most applications. Usually an oxygen cylinder is connected to the ozone generator, though in some more modern setups you may find the oxygen supply has been piped in from a remote cylinder to a neat control panel, which should still be fitted with a main valve and control valve, just like the cylinder used in this demonstration. And the ozone is passed into the reaction flask in a stream of oxygen, and the outlet from the flask is passed through 2 Dressel bottles containing 10% potassium iodide solution. The ozone is best introduced into your reaction via wide bore glass tubing or a sintered glass inlet, as Pasteur pipettes can easily get blocked at the low temperatures used for most ozonolyses. It's a good idea to check that the flow valve on the ozonizer is closed, otherwise when you open the cylinder the flow of gas will go straight through your apparatus in a poorly controlled manner and may blow out some joints. Open the main valve on the cylinder anti-clockwise. If the valves show less than 50 psi, then have the cylinder changed. Slowly open the control valve by screwing clockwise to give around about 5 psi on the dial next to the valve and around 0.4 bars on the ozonizer pressure dial. Now carefully open the flow regulator on the ozonizer so that the floating ball hovers around the 40 to 50 mark, and a steady stream of oxygen is seen to be passing through your reaction mixture and the Dressel bottles. Now you can cool the reaction mixture to the desired temperature, which can vary from -10 to about -70, before turning on the main power switch on the ozone generator. The power dial can now be adjusted to read about 1.5 amps. You will initially see a surge of power to around 3 to 4 amps, but the machine soon settles down to a steady figure again. Ozone is now passing through your reaction mixture, and you will see the potassium iodide solution in the first Dressel bottle turn yellowy brown quite quickly due to liberated iodine, though the second one should stay clear. Note the use of a blast shield in front of the reaction as a useful precaution against the potentially explosive ozonide intermediates. Continue to bubble ozone through your reaction for about 10 minutes. In most cases this will result in a light blue or purple coloration in your reaction, which is just visible in this demonstration. You can check the outlet of the second Dressel bottle with a Draeger tube as shown to ensure that no ozone is being released into the fume cupboard. Now turn off the power switch on the ozonizer and allow the oxygen to continue passing through the mixture for 20 to 30 minutes, during which time the reaction can be allowed to warm to room temperature if desired. The blue colour will fade as excess ozone is flushed out of the system. The cylinder main valve can now be turned off first, and then the regulator valve, and then you'll see the floating ball settle back onto its seat. Finally, close the flow regulator valve on the ozonizer. The ozonide in the reaction flask should be reacted in situ to give the required product without isolation of the potentially explosive intermediates. Typical solvents for ozonolysis are methanol, ethyl acetate, dichloromethane and acetic acid. Never use ethers. Don't use any natural rubber products in this system, for example tubing, septa or teats, as the ozone will react with these. And don't use nitrogen to flush out the excess ozone, as it can form an explosive mixture. The second potassium iodide scrubber shouldn't go more than a little yellow. If it starts to go brown, you'll have to add a third. After you've worked up the reaction, it's a good idea to check the solution for oxidants using starch KI paper before evaporating them to dryness.